Welcome to the normal distribution video. Your learning objectives for this video are understand normal distribution and to know diagrammatical representation of normal distribution. Let's begin by looking at these diagrams. Data can be represented or distributed in different ways. This is how you look at how it is spread out. Okay. So in this example, we're going to look at three histograms. Here, these histograms show the marks of students in three different tests. So you have test A, test B, and test C. In test A, as you can see, the bars at the left is very low, and then at the right-hand side, it's more of like a high score or high bars. So as you know, at the left, it's normally the low score. You start at 0 going up. And also that arrow shows that it's going up in the right direction. Okay, so for A, it is described as left skewed. When it's left skewed, we can also describe this test as mostly the students got high marks. And we can conclude that the test is easy because a lot of students got high marks. Okay, now we're going to jump in test C. In test C, it's the opposite of test A. The bars at the left are high, whereas on the right side where the scores should be high are really low. So then here the bars are low. That means that the students have low grades. Yeah, most of the students have low grades. And we describe this distribution as right skewed. So in test C, most students scored low marks. And we can also conclude that the test is difficult. Okay, now to B, this is symmetrical. What you see on the left side, the red one, is also what you see on the blue one. So it's evenly distributed. So the test B is normal. And you can say that in test B or histogram B, most students found the test neither easy nor difficult. Okay, so B is what we call normal distribution, and you can characterize this by making a bell, and it's normally characterized by a bell-shaped curve. Okay, now let's discuss more about this left skewed distribution. If it's left skewed, okay, the mean is more on the higher part or a higher number, okay, to the right, more to the right. And then the mean and the mode, you will find it at the left of the mean, lower than the mean. Median and mode are lower than the mean. And as a rule of thumb, left skewed distribution is also called positively skewed. Okay, now on the other hand, right skewed distribution, the mean is more to its left, like it has a low value, the mean has low value. And then your median and mode is at its right, meaning that the median and the mode are higher than the mean. Okay? And as a rule of thumb, right skewed distribution is also called negatively skewed. You can also describe it as negatively skewed. Now, for normal distribution, mean is at the middle or at the center. And the mean and mode are really close, or like it has the same value as the mean. They have the same value, both mode and median, or close to the middle or close to the center. Okay. Now, let's check your understanding. Stop the video, look at the pictures, and answer them. Okay, once you are ready, play the video again. Okay, let's check your answers. A is right skewed, normal. Neither, because in C you can't, it's very difficult to tell. So it's neither. D, normal. Neither, left skewed. Okay, for G, because you probably won't see it in the video, G is neither. H is right skewed, and I is normal. So check your work. Okay, now next, let's look at the normal distribution now. Now you don't see the histogram or the bars. What you see is just the bell shape because we're going to describe the characteristic of normal distribution. In a bell curve shape distribution or normal distribution, at its center is the mean. Okay, you can see there your x with a bar on the top because that's how we represent the mean. Okay, now from the mean and within one standard deviation, so whatever is your standard deviation plus the mean, and then mean minus one standard deviation, that area represents 68% of your data set. Now within two standard deviation, now your area is bigger, so that represents 95%. Okay, to look at the whole view, approximately the blue area here is 68% within one standard deviation. Now, after we add one more standard deviation, that will be within two standard deviation, okay, then you are within 95% of your data set. Okay, now if we keep going three standard deviation, that will be that your data set is about 99%. Okay, that's within three standard deviation, and then you still have a 1% remaining at both ends. Now remember, the bell curve is symmetrical, so your area is always divided into half. Okay, so half of the 68% one is bigger than the mean and half is lower than the mean. Okay, so let's have some interpretation on how to interpret it. Okay, still using the marks that we had. Okay, if the mean is 20, mean is always at the middle, okay, here. So the standard deviation is 3. So within one standard deviation, you add the standard deviation 3 to 20, so you will have 23. And then subtract the standard deviation 3 from 20, that's 17. So from 17 to 23, you have 68% of the marks. Now, add one more standard deviation. Okay, so then 20 plus 6, because twice the standard deviation, 3 times 2 is 6, so 20 plus 6 is 26. 20 minus 6 is 14. So this area of your bell is 95% of the marks. So from 14 to 26, it's 95% of the marks. Now, let's have real life problems. Okay. The result of the test are normally distributed. Okay, so the mean score is 56 and the standard deviation is 4. What percentage of students should score between 52 and 60? Okay, let's check. Within one standard deviation, from 56, which is your mean, plus 4 is 60. That's your 60 there. Then 56 minus 4 is 52. So that means that's within one standard deviation. So from 52 to 60, you have the percentage of students score is 68%. Okay. The next question is, how about what percentage of students should score between 48 and 64? Again, we go back to the mean score, which is 56. Let's check two standard deviation. Two standard deviation, your standard deviation is 4. 4 times 2 is 8. 56 plus 8 is 64. 56 minus 8 is 48. That means it's within two standard deviation, so it's 95%. So your answer is 95%. Okay, now how about C? What percentage of students should score over 64? Now, within 64 in letter B, we already said it's 95%. So, out of 100%, we only have a remaining 5%. And in that 5%, if you look at the right side, it is equally distributed to the right of the bell here. So, this part here without the red line is part of 5%, and then the other is 5%. So these two areas, okay, share 5%. So if we divide those into 2, you have 2.5%. So this part here is over 64, and then this part here is below 48. Where did I get my 64 and 48? It's in letter B. Yeah? So here it's from 48 to 64. Above 64 is this area, which is 2.5% or 2.5%. Okay, let's have some other examples. Okay, this time there are 3,000 bars of chocolate, and then the mean weight is 120 grams and the standard deviation is 3 grams. It says assume that it's normally distributed. Now, question A, how many bars would you expect to weigh between 117 grams and 123 grams? So let's check the one standard deviation. 120 plus 3 is 123. Okay, there you go, 123. 120 minus 3 is 117. So from 117 grams to 120 grams is within one standard deviation. One standard deviation is 68%. But we can't use 68% as the answer because the question is how many bars. So we need to figure out how many bars are 68% of 3,000. Okay, use your calculator. You should get 2040. Get 68% of 3,000, or you can do 68 divided by 100 times 3,000, or 0.68 times 3,000. Okay, letter B. How many bars would you expect to weigh between 114 and 126 grams? Let's check. We already know the one standard deviation. Let's check if these values are within two standard deviation. So 120 is the mean. We would like to check it into standard deviation. So 3 times 2 is 6. 120 plus 6 is 126. 120 minus 6 is 114. That means it's within two standard deviation, which is 95%. Again, the question is how many bars? Okay. The number of bars should be 95% of 3,000. So get 95% of 3,000, which is 2,850. Use your calculator, 0.95 times 3,000. Now, the question is, how many bars would you expect to weigh less than 114 grams? Okay, now we know that over 114 grams is beyond two standard deviation. Okay, now it should be like 5%. Okay, so how many should weigh 114 grams? Okay. Find out. It's less than 114 grams. The answer is 75. 5% of the bars are outside two standard deviation of the mean. So just get 5% of 3,000. Okay, grade 11. Now it's your turn to show your understanding. If you don't, just watch the video again or chat with me. I have questions in a document that is posted in Edmodo by grade 11.